bought Tangaroa, the generators were in rough shape, and we needed reliable power to survive Canada's dark winters when solar just couldn't keep up. After months of research, we decided on a DC generator and an AC generator. We found two brand new Kohler engines on eBay, originally from oil sands light stands, and paired one with a custom-built DC generator head from Alibaba. After years of use, did the system work as planned? Is the Alibaba generator holding up? Or do we have to redo the whole system? Let's talk about what was on Tangaroa when we bought her. She had two generators at the time, both AC gensets. One was probably the original Kohler generator, and the other one was an Iveco that was pretty obviously added later on in life. The original generator was in pretty rough condition, and the exhaust wasn't even functional when we purchased the boat. It was also obsolete. You couldn't find parts for this thing anymore. It actually had a really neat thing where it used the generator head to start the engine rather than having a separate starter. It was super weird, but none of it worked like it should.
So what are you doing down here? You said it was your own special...
So what we've got is, when we first purchased the boat, two generators. This one's a 15 kW, that was a 30 kW.
So this is starboard here.
Yep. So
What is it, 15 kW?
this one was 15.
And port?
And that was 30. So this one ran, but was never quite right because they changed the exhaust configuration at some point to be a wet exhaust, and it had a huge leak over in the corner there. Plus it was all set up on 32 volts.
Yep.
So the 32 volts on this generator, actually, there is no starter motor per se. It all does it with the generator head. So without the 32 volts batteries, because we now switched over to 12 or 24 volt, without the 32 volt, the system doesn't work quite so well. So what we've decided is, after we got the batteries installed, this generator, like I said, has never been working, so we were running this one primarily. This is one that ran all the way down from Alaska.
Port.
Yep, port generator. So after we got the new batteries installed,
it doesn't look like much of a generator anymore.
Not anymore. No. So after we got the batteries installed, we were running the generator to charge the batteries for the first time, and this one developed a pretty nasty rod knock. So what that is basically the rod bearing fails, and you've got to tear down the generator and rebuild the generator. Not only that, being an AC generator head, our inverters were only able to charge at about 75 amps. So that gives us a total charging of 140 amps. So it just wasn't going to do it. The charge times would have been too high. The generator would have been super unloaded, which isn't good for them as well. They'll glaze up. So we needed something better. So we made the decision that we were going to go ahead and replace both generators with new units, so we had some confidence when we left on our trip. So we've got this big, huge generator, and the only thing it's being used for is pumping 120 amps worth of 24 volt DC into the batteries. So
that's it.
Complete waste of a generator. So we've decided to redo things a bit, rather than redoing this generator and getting this generator working.
What kind of generators are they? Kohlers?
This is a Iveco, which is an Italian motor.
EVACO?
IVECO.
IVACO.
And then this generator is a Kohler, which I guess they're sold in the US, but they're based on Italian motors as well. So basically both Italian motors. I'm not sure if the Kohlers were Italian back then.
Why do we have Italian motors in an American boat?
I don't know.
Okay.
So anyway, the Kohler actually still ran. The Iveco died at 3,000 hours or so pretty low. So what we've done is, rather than running a big, hefty 30 kW genset to put just a tiny bit of power in the batteries, we've decided to run two DC generators. So no more AC generator head, and the ones that we're getting are a permanent magnet DC, so they're a third of the size. The engine, this is a 2-liter engine. The new ones are 1 liter. The fuel consumption is considerably less. And the beauty of it is that one of the DC generators can charge the batteries at 460 amps. So it's more efficient.
So what does that mean in
fuel,
layman's term?
More amperage.
Charge really fast?
Charges a lot faster. Still take about 4 hours to fully charge those batteries.
But that's like 56 lithium batteries.
It is. And
like, hold on, let me show you the batteries. Coming back. That is a whole battery bank there. Underneath there, 56 lithium batteries. So 4 hours to charge all of those is not too shab.
No. So anyway, 4 hours for charging. So basically we have an engine half the size, both physically and displacement-wise, that is charging the batteries at 4 times the capacity of what this big hefty generator could charge. So all in all, considerably more efficient, which is what we're after on this boat. We're
and what about
trying
this
to
one?
change it all. This one's just old. It's 6,000 hours, which honestly isn't all that much. But it's just an old genset, old generator head. It did run, but just not efficient. We decided on 2 generators, one of them being an AC generator, one of them being a DC generator. Now, when I say AC and DC, that's alternating current, direct current. One's directly powering the batteries, so charging the batteries directly. The other one provides AC power to our inverters, and then the inverters charge the batteries. To build a generator, you need multiple things. The first being the engine that turns everything. For this, we decided on a pair of Kohler diesel engines. We found a pair on eBay. They're KDW 1003s. We think they came from light stands from the oil sands in Alberta or something like that. They were surplus, brand new engines though. They're 1000 cc, 3-cylinder, nice little motors. They're timing belt driven, so they're a little quieter, or so they said. So it was a good power plant to start with. I got new engines.
It's like Christmas.
It's just like Christmas.
So what is it? What are those?
2 Kohler KDW 1003 engines.
But are they for like cars?
Nope, no, they're industrial diesel engines. These are actually made for light stands.
But they're not specifically for generators.
Nope, they're not specifically for generators. They're not specifically for marine. So
Then-
we're going to have to marinize these, which means we're going to have to put raw water pumps on them. We're going to have to put heat exchangers on them. And
I'm guessing we didn't pay the marine cost, which is double any cost of anything.
No, we actually paid half retail for these because they were surplus.
Where'd you get them on eBay?
I got them off eBay.
Off eBay. So now we've decided that we bought 2 of them.
Yes.
But they're so much tinier than the ones we have in the engine room.
So for the 2, we got less than what they'd normally go retail for 1.
Okay, so what are you going to put on it? Show me where. What goes on where?
So these are configured for light stands. So they've got this additional plate on here for mounting, I'm assuming the generator portion of the light stand.
Okay.
So we're getting rid of all of that, and this is going to look like this. And then we're going to build a bell housing on this.
Yeah.
Get a custom flywheel made up that's going to bolt to our DC generator head. And that's going to be DC versus AC. So our charging capability for our batteries will be much higher, and everything will run off the batteries and the inverters.
They're so cute.
If we don't have enough power, we can add more inverters. And if we don't have enough power from one generator, we can crank 2, and they'll combine to make more amperage.
And how long is this going to take approximately?
I would imagine the biggest time sink is going to be the flywheel and the bell housing fabrication work. Don't know exactly how long that's going to take. I got to do some drawings on the flywheel and stuff, and then we got to send it to the machine shop.
But we don't even have the DC generator head yet, so.
No.
That's on the slow boat from China, like literally the slow boat from China.
So once we have the engines, and it was nice that we had 2 identical engines because now I only have to carry 1 set of parts for them. We had to decide on the electrical half of it. So we haven't done the AC generator yet. That'll come in future episodes. It just hasn't been in the cards. But for the DC gen set, to charge the batteries directly, that's better for us for now because we spend most of our time out at anchor. And the DC generator head provides considerably more amperage to the batteries to charge them up. So our generator run times are considerably less that way. What we decided on was a permanent magnet DC generator head from a company called Winter Power on Alibaba. We got to talking with them, and they figured they could build something that worked for our needs. I wanted, first of all, a 400 amp continuous output on it because I wanted this thing to be able to charge my lithiums fast, and that's well within the specs of my lithium batteries. And then it also had a 0 to 5 volt input that I could send from my battery management system that would ramp back the current when the batteries got full, so we didn't overcharge the batteries. So they figured they could do this, and we decided to go with them, and we had the generator head sent from China. After that, I needed to figure out what I needed for controls on these engines. So you can't just have the engine and have it run by itself. Something's got to maintain the RPM on it. Something's got to watch for oil pressure and temperature and do shutdowns in case of faults. And then you have to have something that can actually control mechanically the throttle on the engine, which is called the governor. I chose what was the name of the company? Dynagen, TG350 control module. And what it does is it does all the electrical monitoring. So it looks at the oil pressure, it looks at the coolant temp, it looks at the engine RPM, which I had to make custom trigger wheels for because these engines didn't come with that. So it takes all of that data, decides whether or not the engine is running, not running, whether it's got enough oil pressure, and it's kind of the brains of the whole thing. It then sends data to the governor and tells the governor what RPM the engine is at, what RPM it needs to be at, and the governor just adjusts the throttle to maintain that RPM. The governor I chose was a Governors of America Corporation, EEG 7000, I believe, and it basically sends a signal out to it's a little block about yay big, and it's got a lever on it, and that lever connects to a throttle cable, and that runs the throttle on the motor. So with all those things together, they control the function of the generator. The DC generator head does its own thing. It just requires you to spin it, and that's how it all gets controlled.
And how are we getting them out of here? Because that door is quite narrow.
So we've got to completely disassemble these. So as you can see, this one's partially disassembled. I've got to finish disassembling that, so we'll tear it right down to just a bare block and take it out piece by piece. Same on this one.
It still looks heavy to carry out.
Well, the engine's not going to be the issue. The issue is going to be the generator head, because it's going to be difficult to tear that down to
You can almost carry it the size it is now.
That's probably 300 pounds worth of generator.
You need those lifts that people do, you know, where they do the shoulder straps, the utility guys, they do the shoulder straps, and then they strap it on and they walk between the two of them.
Might end up building a set of those two.
That's what you need.
Engines out.
Yeah.
But anyway, that's
we have a
it.
17-year-old. It's called child labor.
Yep, more or less.
He turns 18 if we wait for a little bit. It won't be child labor anymore.
No, that's true. He'll be of legal age.
We're taking that one all out in pieces too.
Yep, both of them.
I still want to know how they got the washer and dryer in here.
Yes.
Never been hooked up, brand new, sitting in the engine room. We think they came through the ceiling. Still don't know.
Yep.
It's a mystery.
We'll tackle these, get these all efficient, and then after that's done, we'll start tackling those beasts and getting those efficient.
The engines?
More efficient. Used to be whenever you'd start this, you'd see sparks fly out of the...
Sparks fly out of where?
Yeah, sparks fly out of the generator side down here. This is technically the exciter side, but yeah.
Exciter because there are sparks?
More or less. So right now I'm disassembling, so this is the rocker setup, so this whole piece is coming off of here now.
That's what you're doing right now?
Yep. I just gotta...
This one you've already taken all that off.
Yep, that's all down to the bare short block.
And this beast of a yellow thing.
Yeah. Still works fine, just...
Can we sell it? Can we recycle it, make money somehow?
We're gonna try to. This one, on the other hand, probably not so much. I don't think there's many people looking for generators from 1969.
Are you having fun ripping them apart, though? Yeah?
1, 2, 3.
Okay, this is where we really don't want to... Oh.
Wow!
Durba's not impressed.
How you doing, Durba? Hi, Durba. You still floating? You okay? So what's that?
This is the old
Asbestos.
engine muffler.
Take a deep breath. I got a grip on it.
And it's going to swing if I let go here.
Yeah!
I warned you. All right, I got it.
That's very phallic.
Perfect.
Now we have a chimney in the tender.
It's a periscope. All right, well, that was easy.
Nice.
Something from the engine room.
I made a hole.
You made a hole.
I was thinking of installing a dance floor.
Right there? And you're gonna do the boogie woogie woogie in the engine room? Right now it's just a kid trap.
Yes.
But that's where the old generator was.
That's where the new DC generators are going to be. So now that we had all the controls set up and we had the heads where they would function, we needed to marinize these two generators, or one generator at this point. Marinizing is basically mainly to do with the cooling system. So on a car or a generator running on shore, you have a big radiator and a fan that blows through it, and that's what keeps the engine cool. On a boat, that doesn't work so well. As I said, one of our original generators was set up that way, but it's not a very good way to set it up on a boat, because you generate too much heat in the engine room, and that heat is hard to get out. So what they do is they use what's called a heat exchanger. So it's usually a tube that's got a bunch of tubes that run through it. It flows salt water through one direction, and then it flows the fresh water that cools the engine through in a different flow path. These flows don't touch each other. They're separated by the tubes in the heat exchanger, but they do exchange heat, and that's what cools the engines. So to do that, you needed not only the heat exchanger, we needed a raw water pump as well. So something to pump the salt water through the system. I ended up picking up a little impeller pump. Doesn't have to be very big. They're small engines, 25 horsepower, doesn't require a whole lot of water flow. And I had to fabricate and design a pulley system for it to be able to be driven off of the Kohler engine, all the bracketry to hold it on there. It took some doing, but we had it working now. At this point, we had the mechanical side of the generator ready to go. We were still waiting on the DC generator head. Finally it arrived. Time to get that on board. Now, we brought these on board in separate loads. The generator motor, fortunately, was small enough where two big strong men could get it on the boat. And same for the generator head. It was light enough where two people could carry it onto the boat. So I got the help of a friend of mine, Samuele, and it was a bit of an awkward getting it onto the boat. So just be aware.
Okay.
Ready? 1, 2, 3.
Good there.
Do, all the way down to the end of the dock. You okay, Blaine?
Good, bud.
You okay?
This cart is not the healthy one.
That cart?
The cart is not the healthy one.
Exciting, the new generator is in the galley. Where it's supposed to be. Doesn't everybody keep their generator in their galley? But it's got to get down those steps, and we're just trying to figure out how.
I'll try.
Hoppa! Guess what is on the dock? Look at Sam just brought it over, and Sam and Blaine hand bombed it down the dock, and now we've got the generator there, and we're just trying to figure out how we're going to use these shoulder straps to bring it on board. Very exciting though.
Straps.
They're going to harness each other together. My, what a big strap you have, Sam. Crotch to crotch, here we go. Can you fit?
No problem. That's my fingers.
Taking off.
Okay, we're just going to leave it here. We're not
You
going
don't
outside.
want to go up?
I'd go up.
I don't think we're going to be able to, Janice. This is heavy. Now let's just go down. We're going to hurt
Okay.
ourselves if we try to. Now all of the components were on board for installing the gen sets. First thing that we needed to do was get a platform down there. There was original platforms that were under the first generators. They were toast. There was so much rot in them. I'm surprised they were even holding up the original generators. So we redid that. Janice took a big piece of marine ply, laminated a couple together, threw some fiberglass on it, and we had a platform.
Long time since I fiberglassed, but this is Blaine's base for his generator, and he wanted it fiberglassed. I think I got most of the air bubbles out, Most of them are just, yeah. But it's really hard to do the edge. So I just did the matte on the edge, and then I'll cut off that rough side here. And then I'll flip it over and do the other side. At least it's sealed. I can still sand it and make it pretty, and then paint the whole thing. Hopefully he'll be happy with it. Okay, this is a table that's taken forever, or the platform. We're just going to put the last coat on and then let it dry for about 4 days probably, because this paint takes a long time to dry, and then it should be done and ready for the generators.
Now that we had a platform, it was time to put the generator head and the engine together. We had to get some motor mounts for it as well, and all of that once together got set down on the platform. Had to build an exhaust, so that was a bit of time to get that done. And then I had to do all the wiring to put all the control modules together. So I had to wire the Dynagen module to the governor module and get everything working. So that's the old generator. That's the new generator. So once again, old generator, new generator. So see, I've got the heat exchanger ready to rock and roll here. I've got to finish a lot of plumbing, saltwater and freshwater. Got our mufflers going in up here. So this is my current priority. We're also running a Dynagen, which is effectively turning this generator into an electronic generator. So it'll be electronically governed. And it will maintain 2400 RPM as our best RPM for the DC generator. Nice thing about DC generator, this is a permanent magnet model, so it's got no brushes. The only wear component in that entire generator is a rear bearing. That's it. There's no anything in there. Everything else is fixed, does not have any physical friction components. For the starboard generator, I was looking for a new sea strainer, and typical common ones that you find on boats would be, say, Groco or what's the other one? Perco would be another one. We had several on the boat, but they were fairly older style. We had a couple of Grocos. I think we had maybe 1 or 2 Percos as well. But they were in rough shape, and quite frankly, they didn't have very good mounting solutions. So I decided to try a new one that I've never used before. So now I am not sponsored by these people in any way. This was just something that I decided to try. This is a company called Marine Hardware. It's very similar to I think it's the Perco that does them this way, with the clear bowl on the bottom. Same bronze top. But what I like about these is they've got this nice bronze ring here that sandwiches the bowl between the top hat. And they've also got a very nice mounting solution that allows any sort of rotation on them. So you can actually, and you don't have load on the plastic in any way. So you can mount this in any way. You can rotate. So you're not fixed in one specific rotation. And then they also have a little reinforcement nub at the bottom for flex, so that just butts up against the body of the bowl there. So I just found them to be a pretty nice looking solution. As far as engineering goes, it seems to be pretty sound. So we decided to go with this one. As you can see here, I've got some fairly large expansions happening for the through hull, and this is because the through hulls that were already installed in the boat were fairly large. They were 1.5 inch through hulls. So when we redid all the ball valves, we did the True Design, basically like Marlon. They're a glass reinforced nylon. I found they were also very good quality from the feel and the look of them. So anyway, we were kind of stuck with that size, so I've carried it up large size to the sea strainer, so there's no restriction up to the sea strainer. And then I'll also have to neck it down a little bit even coming out of the far side, because the generator raw water system is even smaller than that. The moment we've all been waiting for. Got everything together on the exhaust here. It still needs to be wrapped with insulation, but it's good enough for now for a quick test fire. I'm gonna give it a little fire up. It's not going to stay running because I've got no crankshaft speed sensor on it, so the controller doesn't actually know it's running, so it shuts it down. But it should at least fire anyway. So here goes. Hey, we're in business. Now I just got to get some other stuff happening to make this continue to work, but we are laughing. That's a good feeling. Now on the first startup, everything went pretty well. The engine fired right up, made great oil pressure, coolant temps were perfect. Looking at the DC output from the generator head when we first fired it up, right up to 400 amps. Beautiful. That's exactly what we wanted. 400 amps was what we ordered. After about 20 minutes, the amperage had fallen off, and we had settled at about, I think, 270 amps at that point. And obviously not what I wanted. I was a little upset about that. Phoned the company, back and forth with them. They said, oh, that's just the charge profile. I said, I didn't ask for that charge profile. I asked for 400 amps continuous until I told it to go down. Anyway, long story short, the joys of buying off Alibaba and China, that's what we had. Done some testing here today. Got the generator, it's 400 amp DC generator, and it was only seeing about maximum of like 220. And then after a little while of running, it would warm up and it would drop down to like 170, 180. So obviously something was warming up and creating resistance, either getting a voltage drop or whatnot. So I'm just doing some testing here today. One is I've doubled up the 4-aught battery cables just for testing for now, just to see if that's gonna do the trick for me. Don't mind my back corner back here. Once again, just doing some testing. And I've also put in temporarily, I keep saying that because I'm embarrassed for how all this looks, temporarily put in a larger contactor. So that's a 1000 amp contactor. I had two 400 amp contactors, these little guys here, bundled up together. I'd made a little plates to basically tie them in so they were paralleled. But one of them or both of them were getting a little bit warm. So I've got the new contactor temporarily wired in for testing, and we're gonna try it here just to see what kind of amperage we get out of the battery now, or sorry, out of the generator now. But just after doing the cables alone, without doing the actual contactor, I went from 200 amps to 330 on initial startup, but then it dropped again from 330 down to 260. So the only hot part on the whole system were the contactors. So hopefully this will kind of get those working a little better. We'll find out here. I'm just gonna run it up now and find out. So today I'm doing a little bit of reconfiguration of the genset. Few things that I don't like about it. One of the things, so that's the DC generator head here, this big box, right up to the back of the motor down in here. One thing that I've never liked about this is the fact that it's got all this weight of this box sitting at the back of the generator head. When I originally bought this generator, I thought it was going to come with an external diode module or rectifier module. So I would like to actually extend the wires and relocate the rectifier modules outside of the engine compartment. One, to keep them a little bit cooler, and two, just to make more room inside of the box here. So I'm working on getting this outer frame before I make it somewhat permanent and get the batteries on top of it. I'm going to try to get this frame lifted up and get that rectifier module box out of there, and probably relocated to the ceiling. That's a better view of it here. So basically everything from I'd say this point rearwards is rectifier module. It's two big electronic boxes in there that do all the control. And then you can see the generator head itself is just that little piece that bolts from here to there. So that's a big permanent magnet rotor and a fixed stator. So the rectifier modules don't have to be there, and I'm going to see if I can get them moved to a cooler area, keep them a little cooler, and then I can focus a little bit more on sealing up this box and quieting down the generator, because it's surprisingly loud for how small it is. So yeah, that's my project for the next little bit. We've got some sunny weather now, so I don't need the generator. We're making lots of solar. Once we get into the winter time and we're running this every day, it just doesn't work. So I'm going to try to get this stuff finished up while we got some good weather to make it happen. Just to give you guys an idea of what I have to do to move these rectifier modules. This is what they look like. So all of these wires you see running down the sides here and over here, those are all coming off the stator in the generator. And I've got to extend those to wherever I'm going to be mounting these rectifier modules. So I've got to take every single one of those wires loose on the outsides and lengthen them and move them over to where I am putting the rectifier modules. So fortunately, they're all labeled nicely. You can see they're all easy to make sure you get back in the right place. So it's not terrible, but it's going to be a lot of wiring. So yay me. Now you might ask yourself, Blaine, why would you remove that rectifier module? It was perfectly good where it was, sitting in nice and tidy in the generator. Unfortunately, two things. One, I've got certain need to adjust while the generator is running. One of them is this little trim pot up here at the top, which is my set point voltage. And I can't remember where the other one is. I'll have to find it. But regardless, that's one of the reasons why I want to do this. And two, because I'm boxing in the generator with soundproofing, I wanted to get as much cool air to this module as possible, because it does have a temperature D-rate. So the cooler I can keep this, the more output I've got. So removing it from the inside of the generator box with the additional heat will help keep my amperage up. So I'm going to mount this somewhere. It's going to have a squirrel cage blower that's going to be blowing nice cool air over it all the time, and hopefully that will keep it at peak output, which is what we're after. That's the rectifier modules mounted on the back side of the generator box here. And what will happen is once I seal up this generator box, the air from the generator, I'll actually connect it to there. And when the rotor spins, which is down in this hole here, it will pull air through the rectifier module and vent it out the side where I've got a vent cut in on this panel over here. And that should keep everything cool, pull in nice fresh air, and keep that entire box vented. I like that idea. So we've gone through about 2 years at this point of limping along with the generator as it is. It does seem to work better in the winter time. When it gets really cold, it tends to work better, which works hand in hand with how much power we're generating from solar and everything else. So it's never been a massive panic. So it's something we've always known we're gonna have to deal with. So obviously our Alibaba generator head did not live up to expectations. It gets us by, but it's just not cutting the mustard. So we've shifted to a new plan. I've got 6 alternators that I have already, 2 of which are Delstar 300 series alternators, and the other 4 are Pentex PX833s. These are big alternators. They're 95 pounds. They're enormous, and they're made for continuous amperage output. And when I say continuous, each one of these will do 330 amps. So they should do the trick. You're probably wondering where I got these alternators. I found them online, and they were in Louisiana. And I'm in Canada, so this is difficult for most people. I've still got family in Louisiana. I was born in Louisiana, raised for a good portion of my life in Louisiana, and I still have family in Louisiana. So I had my cousin drive to Ponchatoula and look at these alternators for me. And he drove down there on a weekend, gave me the thumbs up. I sent him some money down, and he took the alternators home with him. So we now had 6 gargantuan alternators and needed to give them up to Canada. My dad just so happened to be visiting in Louisiana at the time. They currently live in Tennessee, but they go back frequently. And he was happy to do some crating for me, and got them all packed up and sent away on a less than truckload shipping up to Blaine, Washington.
This is exciting. Our new alternators are in Canada. So Blaine and I are just heading to the airport right now to clear them into Canada through customs and pick them up. And then where are we taking them? To the shop?
Yep.
I'm so glad Blaine has a shop. Put them in, we have a storage container there because we have a lot of parts, engines, alternators and stuff like that, but this is exciting. Let's see what the alternators look like.
Let it never be said that my dad cannot build a crate. These are new alternators, and there's got to be a screw every 3 or 4 inches. This thing could survive a nuclear Armageddon. It's crazy. Okay, moment of truth. Yep, those are some big ass alternators. I have never seen anything like that before. Now, out of these 6 alternators, I'm only going to be using 4. Now, why did I buy 6? Because they were really cheap for what they are. These are like $3,000 alternators each, and I paid $1,800 for 6 of them. So we're doing pretty well, and they're good alternators. The Delstars are made in the U.S. Not sure where the Pentex are made, but they're good units, and they're made for high amperage. So what I've decided is that Porsche and Stella are 2 engines. Each are going to get 1 alternator, and they're going to be pretty slow turning. I'm not going to ramp up. I'm not aiming for 300 and something amps out of each one of these. I only need 300 amps, 350 amps to charge my lithiums at a good rate. So I'm going to be turning these pretty slow. That'll help them live longer. And I'm also going to be only demanding probably half of their capacity to run. And I think that's going to work out pretty well. And then the other 2 that I'm going to be using are the 2 Delstars. They're smaller package. And I'm going to be putting both of those onto my generator head, or my generator motor, my Kohler. And that's going to be my new DC generator head. So we've got 2 regulators on the way, and you guys will have to wait to a future video to see how we make that work.
Now we showed you a sneak peek of our lithium battery bank. If you want to see the whole build, click on this video right here. Also, thank you so much for watching our brand new channel. And don't forget to subscribe, because next week we're ripping up $30,000 worth of teak.